Today we're going to look at writing equations of an ellipse. Our objectives are to be able to write the equation of an ellipse in standard form, given specific information about the ellipse, and to be able to write the equation of an ellipse in standard form when given it in general form. So as a reminder, this is the standard form of an ellipse, and this is what your final answer should be, what form it should be in at the very end for each of these problems. In example number 1, I give you vertices and covertices, and I give you 2 points. And in this example, I'm actually going to put them on a graph. On a quiz or a test, you won't have this graph, so I'll show you some ways to do it when you don't have it all drawn out nice and neat for you. But for our first example, I'm going to do this so you can see. I have -1, 6, and -1, -2, 1, 2, and -3, 2. As you can see, my vertices are further apart, my covertices are closer together. So what's important from this is my center, and I can tell right now by looking at that or finding the midpoint that my center is at -1, 2. So when I'm actually writing my equation, I can now, sometimes kind of filling out this like little shell makes it easier. I know it always kind of looks like that, but since it's a -1, I'm going to write x plus 1 quantity squared, and then y minus 2 quantity squared. Now all I need to know is how much I move left to right and up and down and square those values. So from here I can tell that I move left and right 2 spaces, which means my a value is 2, which means my a squared value is 4. I can tell that I moved up and down 4 units, so that means my b value is 4, which means my b squared is 16. And that's my equation in standard form. But what if I don't give you a graph, which I'm not going to on a test? I'm just going to have you draw it out yourself. So how could you do this problem then? Well, I know my vertices are further apart, and if I look at these 2 ordered pairs, the y value stays the same, but the x moves. So since the x moves and those are further apart, I know this ellipse is going to be short and fat. And I know that I have 7, 3, and 1, 3, and I know 7 is further to the right, so I'm going to do 7, 3 on the right, 1, 3 on the left, which means my covertices are up and down. I can tell that 4, -2 is going to be lower than 4, 8. And again, I know I don't have it all plotted out where I can count, but I should be able to easily figure out where the center is. Now the center is the average of any 2 of these points. So I could add and divide by 2, or I could notice that this point lines up with 4, 8, and 4, -2, so they both have an x value of 4. It lines up with 1, 3, and 7, 3, which both have a y value of 3. Or again, take the midpoint or average of any 2 of these points that match up, the vertices or covertices, to find your center. Now that I have that, I can write x minus 4 quantity squared plus y minus 3 quantity squared equals 1. Now I just need to figure out my movement. Left and right, again, a lot of students who try to graph this and put all these little tick marks usually make a mistake because they don't draw it big enough, or their tick marks are too close and they can't count. It's actually a lot easier. Let me put the center in here so you can see. It's just to look. I'm moving left and right, which is changing in my x value. I went from a 1 to a 4, which is 3. And if I go from a 4 to a 7, that's also 3. I like to double check to make sure they're both the same, to make sure my center is correct. Well, if a is 3, that means a squared is 9. Now let's do the up and down motion. So if I move up and down, I go from -2 to +3. Well, that's a total of 5 steps. If I go from 3 to 8, that's also 5 units. So 5 and 5, that's my b value, so b squared then would be 25, and that's my standard form. But what if I don't give you vertices and covertices? What if I give you, say, covertices and the 2 focal points? So again, I'm going to graph this one just so you can kind of see. So my covertices are at 2, 0 and 2, 4. My focal points are at 2, 1 and 2, 3. So right now, since these are my covertices, I know it's going to be a little bit wider than it is up and down. So how can I use this to help me? Well, I can tell that my center is right in between these, right? Because it's going to be the average of the 2 focal points or the 2 covertices. So the center right now is going to be at 2, 2. So I can take that and start to fill things in. X minus 2 quantity squared plus y minus 2 quantity squared equals 1. But now again, I need to know my left and right and up and down motion, or movement. So I don't know how much I'm moving left or right, but I can tell up and down. So up or down from my center to my co-vertices is 2. So up and down is the b value, so I know it's 2, which means b squared is going to be 4. But I don't know what the a is, or what the a squared is, and that's what I need. But I do know what the c value is. Now c is how much we move from the center to our focal point. So I moved up 1 and down 1, so c is 1, which means c squared is also 1. So I'm just going to kind of work backwards of how we found c. Normally to find c, we take a squared minus b squared, take the absolute value of that because we don't know which one's bigger usually, and then take the square root. So I know a squared minus b squared equals c squared. Again, we're adding for an ellipse, so I remember that I'm subtracting my a squared and b squared. Now I know a is going to be larger than b because b were my co-vertices, which are the smaller ones, and a are my vertices, which is going to be a larger number. So I can do the larger number minus the smaller number. Well, I don't know what a squared is, but a squared minus 4 should equal 1. So if I add that, a squared is equal to 5. Well, and that's what I care about. I don't care what a is, I care what a squared is. So I know I have 5 and 4. And you can always work now from our equation to see if it works. If I want to know my c value, I'd do 5 minus 4, which is 1. The square root of 1 is 1. So that means I'm going to move up 1 and down 1, which is what we had to do. So let me give you another problem. Again, it's not drawn out, and if you notice the numbers are a lot bigger, but I give you the vertices are at negative 2, 15, and 12, 15. Again, the y stays the same, and the x is changed. That means it's going to be wider left and right. I know 12, 15 is to the right. Negative 22, 15 is to the left. And I know my center is going to fall right in between those, but I was also given the focal points, which is at 3, 15. Oh, and that should be horizontally the same as these, so I'm going to put one at 3, 15. And then I know I also have one at negative 13, 15. And that'll help me find the c values. So let's first think about what the center is going to be. I know the y value should be 15, because they're all at 15. But how do I find the x part? Well, I could pick either the focal points or the vertices and add the x's and divide by 2 to find the average. I'm going to use the easier, the smaller numbers. Negative 5 plus 3 is negative 10. So negative 13 plus 3 and divided by 2. So that's negative 10 divided by 2. So I get negative 5. Okay. So now I know my center is negative 5, 15. So I'm going to write x plus 5, quantity squared plus y minus 15, quantity squared equal to 1. Again, I know the vertices, okay? So how many spaces did I move? Well, if I go from negative 22 to 15, negative 22 to negative 5, or from negative 5 to 12, that's a total of 17 units, left and right. So I know that left and right is my a value. So a is 17. Okay. B is my up and down, which I do not know. And c is how much I move to my focal points. Well, if I'm at negative 13 to negative 5, or negative 5 to 3, that's a total of 8 spaces. So again, a squared is going to be 289. B squared I do not know. And c squared is equal to 64. Because these are the vertices, I know that's actually the larger number. So if I take the larger number minus the number I don't know, my b squared, it should equal 64. So negative b squared equals negative 225 if I subtract. So that means b squared equals 225. Okay. So again, what goes underneath here? Well, a squared is 289. B squared is 225. And that would be my final answer. There's my center. I have my a squared, which is left and right, my b squared, which is up and down. And again, if I do 289 minus 225, I get 64, which means I'm going to move left and right 8 spaces. Our last two examples deal with going from general form to standard form. So to do that, we're going to have to do some completing the square. Okay, and if again, remember my final answer, I want to look something like this. And I'm going to have my quantity squared my quantity squared. So we need to take this and make it look like that. And if you notice, I want these parentheses squared or my binomial squared, so that means completing the square. So, a couple of things. This is going to be a little bit different than what we did with parabolas, because parabolas were easier and circles were easier because, well, first of all, parabolas were easier because only one value was squared. Circles were even easier, even though x was squared and y was squared, but because we moved for a circle up, down, left, and right the same amount, the number in front of x squared and the number in front of y squared is always the same. But you look here, I have a 12 in front of x squared, a 5 in front of y squared, so I can't just divide everything by my coefficients. So what I'm going to do instead is I'm going to move the x's together. I just put them in parentheses to keep them separate, plus. I'm going to have the y's together. Okay, and then I'm going to move my number to the other side. Now this is what we did back when we did completing the square to put a parabola into vertex form, is I want to factor out the number in front of my x squared. So it's going to give me x squared minus 4x. Now that I have a lead coefficient of 1, I can do the plus blank for my completing the square. In my second part, I want to factor out a 5 to leave me with y squared plus 6y. Now it's ready for completing the square, plus blank equals. I have 27 plus blank plus blank. So I have to keep the 12. Most students forget that, so you have to make sure we don't lose that. X, half of negative 4 is negative 2. When I square negative 2, I get 4. Plus 5. Y, half of 6 is 3. If I square 3, I get 9. Now this is the part you have to be careful with. This number in the front affects that 4. This 5 affects the 9. So 12 plus 4 is actually a positive 48, which means I have to add 48 to the other side. 5 times 9 is a positive 45, which means I have to add 45 to the other side. So, equals, now if I add this up, let's see, this is going to give me 75 between those two, plus 45. 80 is 120. But remember, this is supposed to equal 1, so I have to divide each term by 120 to get my final answer. So, if I reduce, because we don't want to have a number in front of my parentheses, I have x minus 2 quantity squared. 12 goes into 120 10 times. Okay. Plus, again, I want to keep it as y plus 3 quantity squared. 5 goes into 120 24 times, equal to 120 divided by 120 is 1. So now that I have this, that would be my final answer. I'll just write it up here so you can see it again. X minus 2 quantity squared over 10, y plus 3 quantity squared divided by 24. And that's all you need to do. Let's look at one more. Again, I want to keep the x's together and the y's together. So the x's, and if you want to factor it out right away, and I'm going to show you that this time you can, you don't have to put in parentheses and then factor it out. Here are my x's, so I'm going to factor out a 4, and I'm left with x squared plus, if I do this, it ends up being 16x plus blank. Now if I look at the y's, I don't have to factor anything out, so I'm just going to put plus y squared minus 12y plus blank equals, and again, move this to the other side, change the sign. A lot of students just write 288 over here. Plus blank, plus blank. So I have 4, x plus 8, because half of 16 is 8, but if I square the quantity, I get 64, plus, I don't have to worry about a number in front, y, half of 12 is 6, negative 6. Quantity squared, again, if I square negative 6, I get 36. But I have to worry about this number in front. And remember, this is always imaginary 1, so if you want to think of it that way, here I'm truly just adding 36, so that one's easy. But 4 times 64, 6(1) is 256, so that's what I have on the right-hand side. Equal. If I do this, okay, if I look at these two, it's negative 32 plus 36, because when you do order of operation, you go left to right, so these negative 32 plus 36, and I add those, I get a positive 4. But again, I have to divide everything by 4. So when I divide everything by 4, I'm going to get x plus 8 quantity squared over 1. And we typically, I know you normally don't write 1 in a denominator, but for our equations of an ellipse, it's best to do it just so you know that that number is down there, plus Nothing reduces here, so I have y minus 6. Quantity squared divided by 4 equal to 4 divided by 4 is 1. And that's my standard form. I hope you feel a little bit better about writing equations of ellipses, whether you're given specific information about the ellipse or if you're given the general form.